Now we are going to solve another question, okay, which is again the in which you find work done with the help of force and displacement graph. Okay, let me draw the graph. Just wait a minute. Okay, so this is force axis, okay, and this is displacement, and this is force y-axis, which is force, and this is displacement. This is displacement. Okay. Uh, okay, so displacement is some. Okay, this is the force. So let me write down the values. This is 10 Newton, okay, and this is 1 meter, and this is 8, and this is 2 meter, okay, and this is 4, and this is 6. So we have to find work done from when object displaced from x is equal to 0. Okay, not x is equal to 0. When object displaced from x is equal to 6 to x is equal to x is equal to 0. Okay, we have to find work done in this process when initial position of object is 6 and final position is 0. Okay guys, now listen. So what is the work done? Basically work done is dw is equal to f dot dx. You know it, vector f dot dx ds. What is the displacement, and ds is basically vector ds is dxi plus dyj plus dzk. Okay, now displacement is only taking place only along x-axis. Displacement taking place only along x-axis. So dy, what is the dy? Dy is 0 because there is no change in y coordinate. dz is again 0 because there is no change in z coordinate. Okay, so these two guys are going to be 0. So what is the displacement? Displacement finally become dxi. Okay, you have to think it in your mind. Okay, it is not necessary to write down on copy, but you have to think it. Okay, and okay, we are not going to find out what is the equation, okay, because it's the graph is so simple, so it is unnecessary to find out the equation. Okay, you may try to first write down the equation, then solve it. I know that's a lot of combustion happen in that process. We are not going to find the equation. Okay, equation of force. So the force will be some vector like this, f is equal to fx, which is this graph, equation of this graph, fxi plus 0j plus 0k, because there is no force along z y axis and k axis. Okay, so dw will simply become, you have to think it in your mind, f x I plus 0j plus 0k dot and dot product txi plus 0j plus 0k. Okay, and this dot product, so this will become fx dx. We have to keep limit, so displacement is taking place from x is equal to 0 to x is equal to 6, so 0 to 6. Okay, and now this is basically the area, this is the basically area. We have to think about magnitude. Okay, and it will be positive or negative, but it is basically more or less area. Okay, this area we have to find out total area. Okay, we have to subtract it, add it, okay, according to sign, but we have to find basically this area, total area. Now, okay, so let's consider about the sign. Actually, if we write down the equation, then this automatically adjusts the sign. We have to not bother about sign, but actually we are not going to find out the writing down the equation. So we first should bother about the sign. We should think about the sign. Okay, now listen here, this is the 4, this is 4. Okay, so here the force is negative, the force is negative. This means force is acting along this direction. Okay, force is acting along this direction, and and displacement is also taking, because 6 to 4, direction of displacement is along this. Okay, this is the force, this is the displacement, so both are in same direction, so work will be positive. Why? Because angle between them is 0. Okay, because 0 is 1, so work will be positive. So should I write, so this area will be positive, so let me write down this area plus, what is this area, this length. Okay, I had not given it, so let me give it 5. Okay, 5 Newton, minus 5 Newton. So what is the work done? Work done will be plus 5 into 2, displacement is 2 here, so this will be 10. Okay, W1 from 6 to 4. Okay, now after that, this is the direction of displacement. Okay, displacement taking place along this direction, so direction of displacement is this. Okay, this is the displacement direction, and after 4 meter, the displacement, the force vector become positive. Okay, the force is in this direction, the force is in this direction, this is the force. Okay, no, so what is the angle between them? This is the, okay, this is the displacement, this is the force. What is the angle between them? 180. Okay, what is the angle between them? Angle between them is 180. So so work done will be negative, so this is W1, this is, what is W2? W2 will be, work done will be negative, so minus, I have just give sign, and this area. Okay, we have to find out this area. So this is the 2, this is 4, this is 2, so this length will be 2 from here to here. Look at my pencil movement, this length will be 2 from here to here, this length will be 2, and and this height from here to here, this height is 8, so 2 into 8, that will be minus 16, that will be minus 16 joule. This is joule, this is joule. Now we have to think about this portion also, this area also. Okay, from 2 to 1. Okay guys, so this height, this length is, this height is 10 Newton, this height is 10 Newton. Okay, and again here the same thing happening is here, the displacement taking place along this, and the force vector is along this. Okay, the force is positive, so angle is 180 degree. What is the angle? Angle is 180 degree, 180 degree, and so dot product will be negative. So here W3 is a negative quantity, that will be minus, I have just give a sign. Okay, and this length from here to here, this length is 1, so 10 into 1, that will be minus 10. Okay, joule. Now we have to think about this area also. So here we have to Okay, we have to think this area. So this is a right angle triangle, and this height from here to here, this is the 10 and this is 1. So and work will be, the force is positive, but displacement taking place in negative direction. This is the direction of displacement, this is the direction of force. So angle between them is 180, and so it will be a work will be negative. So W4 is equal to minus work will be negative 10. Okay, work will be 1 by 2 area of this right angle triangle. So 1 by 2 into 1, this length is 1, 0 to 1, this length is 1. Look at my pencil. Okay, look at my pencil. 0 to 1 into, and this height that will be 10 into 10. So this work done will be negative, and which is minus 5 joule. So what is the W net? Work net is equal to, this will be summation of all this quantity, algebraic sum. Okay, so this will be 10, this is first W1, then second minus 16, then again 10, W3 minus 10, and that will be minus 5. So if look at this, so what is the work done? W net is equal to minus 21 joule. Okay, so net work done will be minus 21 joule. Okay guys, so this is the method. You what is requirement, just be careful, just think about what should be direction, and this we will talking about area, etc. Then you are able to solve it. Okay, thank you for watching.